Okay, the last problem in 2.3 that I want to go over with you is on page 265 in y'all's textbook. So this gives you a graph, a bar graph. And what you can do with this bar graph is translate this into a function by putting these as points. So like, let's see, this is average carbon dioxide concentrate parts per million, 317 parts per million. And this was average global temperature in degrees Fahrenheit. And this is dealing with 1960, 1970, 1980, and so on. So this is this data transferred into a scatter plot. So the problem is, let's see, the build up. It is shown on the scatter plot is a line that passes through or near the 6 points. So we would create a line of regression by going through the points. Write the slope-intercept form of the equation using function notation. So what we are asked to do is we are going to look at 2 points, and we are going to write the equation using those 2 points. So this is just like what we were doing before. So I won't show y'all what the answer is, but we're going to look at these two. It's in your textbook, but I don't want to show y'all the answer. So it's saying 326 and then 57.06 is one of the coordinates. Sorry, you couldn't see that. And then the other coordinate was 385 and 57.99. So using these 2 points, we are going to write the equation of the line. So the first thing you do is find the slope. So it says x1, y1, x2, y2. And we subtract the y's. So 57.99 minus 57.06 over 385 minus 326. And so when we subtract those, what is that one? 0.93 over, if that was 6, that'd be 60, but it's 59. It's one less. And then when we divide that, we're going to put it at 0.02. So that is our slope. Make sure it's right. Yeah, so we'll round 0.02. So that will be our slope. Then we use one of these points and do the point slope form. So y minus y1 equals m, x minus x1. So it's y minus 57.06 equals the slope, x minus 326. We distribute and then add this to both sides. Y minus 57.06 equals 0.02x minus 326 times 0.02. 652, 6.52. Add 57.06 to both sides. We get y equals 0.02x. And then we need to subtract those, which gives a positive 50.54. So that is the equation of the line that best fits that graph and that bar graph, which was right here. Do y'all remember the way to use these points to do the line of regression in your calculator? Anybody remember that? Okay. We would go to stat, because we're going to have to compare these, which this might be later on, but go to Stat and then go to Edit. And then L1 will be all of your X values, and L2 will be all your Y values. So our values would be, let's see, our X value is 317, 326, 339, 354, 369, 385. Those are the X values. And then the Y values are here. 57.04. Oh, I need to delete that. Make sure to go up to L2. 57.04, 57.06, 57.35, 57.64, 57.67, and 57.99. And once you get your L1 and L2 in, then you go to Stat, and we're going to calculate our linear regression. So I'm going to put that in. Stat, over to Calc, and down to number 4, linear regression. And then you push Enter, and it calculates the equation. So this would be the exact linear regression equation using all of the points, taking all those points into account. So this would be y equals 0.01x plus 52.5. Which is similar to the one we found by just using 2 distinct points. Okay, so your assignment, that number 18, its last problem, was a problem similar to this. You don't have to do this, but this will come in later. I wanted to go ahead and introduce that to y'all. Okay, this we'll finish 2.4 tomorrow, and then y'all do the 2.4 assignments.